Hey guys, yo, this is Mr. O, and today we're gonna learn about 3.1 solving system of equation graphing. Some review. Most of this topic have been covered in Algebra 1, but we're here to go back and put some twist. Okay, so in solving system linear equation, it is when two equation are given or could be more, and if they intersect, that is your solution. Okay, and there are times that two lines intersect, and that is considered to have one solution because they intersect only one time. Okay, sometimes the two lines are coincide. They are exactly the same line, so every portion of the two lines intersected. That's why it's infinitely many solution. And there are times when the lines are parallel because they have the same slope and different y-intercept that they don't intersect. That's why it's no solution. So let's graph this 15x minus 6y equals 0. 5x minus 2y is equal to that. Okay. There's so many ways to graph this one here, but what I would do is just I'm gonna solve for the y here. 15x is equal to 6y divided by 6. This will become, these are divisible by 3. So 5 over 2 equals y. So x. So starts at the origin. 1, 2, 3, 4, 5 over 2. 2, 3, 4, 5 over 2. And reverse 1, 2, 3, 4, 5. All right, there you go. That's my. Make sure you use your ruler to make the best perfect straight line you can have. Label it. Okay. I'm gonna use a different color here. Negative 2y equals negative 5x plus 10. Divide everything by negative 2. Y is equal to 5 halves x minus 5. 1, 2, 3, 4, 5. You can tell that the slope here is 5 halves, and the slope here is 5 halves. We expect to have parallel lines. 1, 2, 3, 4, 5 over 2, over 2, over 2, over 2 here. You can tell that the black and the pink line are parallel lines, so no solution because they don't intersect there. Okay, I need you to pause and try to do this on your own. Okay, all right, so there you go. I know you paused already and you have tried it. Let's see if we can have the same answer. I'm gonna do for this one here. I'm gonna do the x and y intercept, a different method. The intercept here will become what? Negative 1, so 0, negative 1. And this one here, I'm going to cross it out. The x-intercept here is at what? 2, 0, is it right? Yep. So 0, negative 1, 2, 0. So I know the slope is 1 over 2, right? So 1 half. This is my line for the blue equation. And then let's try the green one here. I'm going to do the x and y intercept again. Y there is equal to y intercept is 0, negative 1. And x intercept is also going to give me 2, 0. They're perfectly the same, right? So since it's perfectly the same, this will be all real numbers or infinitely many solution. Okay. Positive. Okay, this one here is slightly different. It's a linear and an absolute value. Okay. Sorry, guys, I'm still sick. I'm just doing this one here to make sure you have a lesson today. Y equals 2x plus 2, you go to 2, up 2 over 1, up 2 over 1, up 2 over 1, down 2 left, down 2 left, down 2 left. Okay. That's my red line. And then the next one is I'm going to use the blue one here for the absolute value. We know it's inside. Minus 2, we go to the right 2. And there's a slope of 1 there. No compression or stretch, so 1 up and over. Reflection, reflection. You can tell that the absolute value in the line linear graph intersect at one point, which is at 0, comma 2. So one solution. Okay, very good. When you try this on your own, pause and do it on your own, okay? All right. So this one here is same thing what we just did. Right, do reflection. And then the next one is the pink one. I'm gonna go right 1, up 5, 1, 2, 3, 4, 5. And it's negative, so it's gonna go down 1, over, down 1, over. Reflect, 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 reflect. And you can tell that the two absolute value graph intersected at 1, 2, 3, 4, 4, comma 2, and at this point here also, negative 1, 3. So there are two solutions here, two solutions, okay? Meaning of that one, if you plug in the negative 1, 3 here to both equation, it will work. Let's try it, okay, to check that, checking. So this is my x, this is my y. You can plug it to any of this equation. Let's drag it to the red one. So 3 is equal to absolute value of negative 1 minus 2. 3 is equal to negative 1 minus 2 is absolute value of negative 3. 3 is equal to 3. It's true. If you try to the next one here, 3 equals negative absolute value of negative 1 minus 1 plus 5. 3 is equal to negative, this is equal to negative 2 plus 5. This will become positive 2 times negative is negative 2 plus 5. It's 3 equals 3. So it will work. Even you try with 4 to it should work. That's the algebraic proof of that one. Okay, next. Let's try this orange one here. Minus 1, we go right 1. There's a vertical stretch with scale factor of 2. That means you're going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay, so my graph is going to go that way. So it's a become narrower. And then let's try this light blue here. X plus 2, I'm going to go left 2. Up 1 over, up 1 over, up 1 over. All right, there you go. If you notice, the graph crossed twice on the same wing of the orange one here. So it crosses at 0.02 and 1, 2, 3, 4, comma 1, 2, 3, 4, 5, 6, 6, 4, 6. Okay. So class activity, create a system of equation based on the solution you were given. Create a system of equation, then graph your equation to check for accuracy. So you're gonna make a system equation wherein the answer has to be 2, 1. They should intersect at 2, 1, but you're gonna make your own um, system. Okay, I'll leave this to you to create a system. I'm not gonna do it because there's so much possible answer here. So I'd like you to make your own and then check your equation based algebraically. The one I showed you, that you plug it into the equation. Okay. So you can make a linear and an absolute value. You can make two absolute value. Okay, or both lines. Okay, linear equation. And this is your homework, page 141, 3 and 5, and graph and save the number solution of this two extra problem. Okay, there you have it, a part of your lesson for today. And we still have 3.2 to do today. I'll share the video on the next slide. Okay, and as always, kaboom.